Hello LabTurtles. In this video, let us talk about displacement reaction. Displacement reaction is also known as single displacement reaction. When I was in school, I was a very dorky, nerdy type of a kid. So there was this group of people who I admired a lot, and while I did not have many friends. So I always wanted to be a part of this bigger group. So what do? This group had a rule that they would only allow these 6 people and they would not allow anyone from outside to enter in the group. I had an idea. I thought, why don't I just go over there and see a kid who's not as strong as I am and I'll just knock him off. So that's what I did. I went over here and I found this kid who was not as strong as I was. I knocked him off and then I was the new member of this group. Easy peasy, right? So displacement reaction works very much in the same way. There is a less reactive metal in its aqueous salt solution, and then there is a more reactive metal which comes higher in the reactivity series. So this metal just goes over here and knocks off or displaces the less reactive metal from its aqueous salt solution. And so we get a new salt solution and we also get a new metal which has been displaced from here. So that is what a displacement reaction consists of. We will understand this in a better way by looking at various examples. The first example is a very interesting one and something which is asked very often in boards exams. So what are we doing over here? In a test tube, I have taken some blue colored solution of copper sulfate and I have dipped an iron nail in it. Iron nail is going to be grey in color. I leave this setup for a few hours. After a few hours, when I go back to the lab, I see that the color of the solution has changed. It has now become pale green in color. And there is a reddish brown deposit on the iron nail. Upon further investigation, I found out that this green colored solution is ferrous sulfate. And this iron nail has become reddish brown because there is a coating of copper on it. So why is this reaction taking place? This reaction is taking place because iron comes higher in the reactivity series. It is more reactive as compared to copper. So it simply knocks off copper from copper sulfate solution. Let me show you with the reaction. So we had iron nail that reacts with this copper sulfate solution. Now iron is more reactive as compared to copper, so it's just going to take the place of copper. We are going to get ferrous sulfate, which is FeSO4 plus copper. Remember, the colors of all of these is very important, and also the two observations. So let us write their states. This is solid, this is aqueous, this is again aqueous, and this is solid. Let's move on to the second example now. In this example, potassium reacts with aqueous solution of zinc sulfate. So potassium is reacting with zinc sulfate. Zinc sulfate will be ZnSO4. Because the valency of Zn is 2 plus and sulfate is 2 minus. So 2 and 2 get cancelled, we get ZnSO4. Now potassium is more reactive as compared to zinc. So potassium is just going to knock off zinc from here and it forms potassium sulfate plus zinc. What is the formula of potassium sulfate? Potassium is K plus, sulfate is SO4 2 minus. So potassium sulfate will be K2SO4. K2SO4 plus we also get zinc. Let's write the states of these substances. This is solid. This is aqueous salt solution, aqueous and solid. Remember, many a time students make this mistake. They simply bring K over here and remove Zn. So instead of writing K2SO4, which is the correct formula of potassium sulfate, they just write KSO4. That wouldn't be correct. You have to consider the valencies of these ions when you're writing the chemical formula. So let's balance it. If we write a 2 over here, now it's balanced. So shall we see the next example? In the next example, zinc reacts with potassium sulfate. So we have zinc, it is reacting with potassium sulfate. What happens here? Now zinc is less reactive as compared to potassium. Therefore, this reaction is not going to take place. There would be no reaction in this case because zinc is less reactive than potassium. It cannot displace potassium from potassium sulfate. So this was about displacement or single displacement reaction.